Differential Calculus 2019, question 10b. A particle of mass m falls vertically downwards due to gravity. At time t, the particle has speed v, and it experiences a resistance force of magnitude kmv, where k is a constant. The initial speed is u. Show that v is equal to g over k minus g over k minus u times e to the power of minus kt at time t. Okay, there's a little bit going on here. Let's have a look at our forces diagram first up here. So we have particle P, its mass is m, I should have underlined it, and it falls vertically downwards due to gravity. So mg going down. This resistance force kmv is in the opposite direction. It's falling under gravity, so my acceleration is down this way, and the forces at play equals mass times acceleration. So we have mg minus kmv is equal to ma. Dividing by m, we're going to get g minus kv is equal to a. Now, what else is a equal to? If you might have seen in the 2019 part A, we showed that v is equal to u plus at, where u will be a constant. So dv dt, differentiating v with respect to t, is just going to leave me with the constant in front of it, like differentiating 5x will be 5. So we're going to left dv dt as a. So we can say that g minus kv is equal to dv dt. There's a kind of clue on the question here. You can see the x is dx and this number on the bottom. So we're dealing with v here. So we want to bring these v's together. So I'm going to multiply across by dt and divide across by g minus kv, or they just swap places. Dt is equal to dv over g minus kv, which is this note that they will always give you it in this question when you're asked to differentiate and integrate. So if I write it like this, dt is equal to 1 over g minus kv dv. So if I integrate this, I'm going to get t on the left, and I'm going to get some information on the right, which will enable me to simplify it down and get my answer. And the values I'm integrating it between, if it started at 0 and went to 4, we'd integrate between 4 and 0. We're at this time, this speed at time t, so we're going to integrate between, it started at u, which is this u up here, and now it's at v. So we're going to integrate between v and u, and if we integrate dx, we get x. If we integrate dt, we get t. So it's between the starting point of 0 and time. So that's just going to give me my t all the way down. And if we integrate this guy, it's based on what they've given you up here. We're going to integrate 1 over g minus kv between v and u. And you can see that they're telling you what the answer is here. 1 over b. The b in this case is minus k. So we're going to get minus 1 over k times the natural log. And you can see here, it's just of the bottom. And the bottom we have is g minus kv. So it looks probably a little bit more complicated than it is. And the bands are v to u. So if we were integrating with respect to x, whatever values we get here and here, we put in for x. We're integrating with respect to v, so we're going to replace v, firstly with v, and then with u. So let's do that for t. Minus 1 over k by the natural log of g minus kv. And it's going to be minus 1 over k, so I'm just going to change that into a plus 1 over k by the natural log of g minus ku. And if I multiply by k and just switch these two around, I'm going to have the difference of two logs, which we know is a division from our log rules. So tk, or kt, is equal to, and I'm going to put this one first and this one second, is equal to the natural log of g minus ku minus the natural log of g minus kv. And that's going to give me the natural log of g minus ku over g minus kv. Always the first one over the second one, and that's equal to kt. Now, to get rid of my natural log on the right hand side, I have to raise the left hand side to the power of v. So e to the power of kt is going to be equal to g minus ku over g minus kv. Just flick back up and we can see we're trying to solve it down for v. Okay, so let's try and isolate v within this equation. So if I multiply by g minus kv and divide by e to the power of kt, I'm going to get g minus kv on the left, and I'm going to get g minus ku over e to the power of kt. And there is a clue in the question. If you look at it, we're looking for e to the power minus kt. So if I bring this guy up to the top, it's going to change the indice from a positive to a negative. So g minus kv is equal to g minus ku by e to the power of minus kt. And if I bring the v to the right and this guy to the left, I'm going to have a positive v, but I'll leave the v in there. So kv, that's it, bringing it to the right, is going to be equal to this g minus the other guy. So minus g minus ku by e to the power of minus kt. Now I want to divide by k to get v on its own. So v is equal to g over k minus g minus ku by e to the power of minus kt over k. And if we separate this guy into two parts, you'll see that the k's will end up cancelling. So we get v is equal to g over k minus g over k. Now both of these are by e to the power minus kt, and we'll factor it back in a minute. So g over k by e to the power minus kt, and we have a minus here and a minus here, so it's going to be plus ku over k times e to the power minus kt. And this is where we're going to get that u within the question. So v is equal to g over k minus, now what's common to both of these? We have e to the power minus kt, but they want it at the end. So let's just put it at the end. G over k plus u. Now is this going to be a plus u? A minus by a minus is going to give me a plus. So this has to be minus. Just be careful at this point with the sign. And you can see that's what they were looking for in the question. And that's going to be by e to the power of minus kt. So just check back up. And you can see that this is what they were looking for in this part of the question. Part 2 of this question, if u is equal to 9.8 and k is equal to 0.98, find the distance traveled by the particle in the first 4 seconds. Well, we have v, and we know v is ds dt. So that should enable us to figure this question out. So v is equal to, if we fill our variables in, g we know is gravity, 9.8 divided by k. Okay, these will divide in, straightforward enough, minus, again, 9.8 over 0.98 minus u, which we're told is 9.8 by e to the power of, and again there's a k in here, minus 0.98t. So we tidy this up, velocity is 10 minus 10 minus 9.8 by e to the power minus 0.98t. So that's going to be 10 minus 0.2 e to the power of minus 0.98t. So that's ds dt. So to get s on its own distance, we need to have ds on its own. When we integrate that between s and 0, we get back to s. And we're looking at 10 minus the integral, and it's the first 4 seconds between, is it 4 seconds? 4 seconds, so between 4 and 0, 10 minus 0.2 e to the power minus 0.98t. So integrating this, that was an s, not an integral. Integrating this on the right, e to the power of at goes to 1 over a e to the power of at. So we're going to get the 10 is going to go to 10t, increase the power, divide by the power, and then we're going to get minus 0.2 by 1 over minus 0.98, so that's going to give us a plus 0.2 over, or time, if you want to do times 1 over 0.98, and that's going to be by e to the power of minus 0.98t between 4 and 0. So just tidying this up a bit, 10 times t plus 0.2 over 0.98 by e to the power of minus 0.98t. So putting 4 in, so set this up in your calculator, we're going to get 10 by 4 plus 0.2 over 0.98. It's going to be a small number, e to the power of minus 0.98 before is 3.92. And then we're going to have minus 10 by 0 is 0, minus, and this is just going to anything to the power of 0. So we put a 0 in here, we're going to get e to the power of 0, which is 1. So we're just going to get 0.2 over 0.98. It's actually a plus here, sorry, not a minus, a plus. So this is going to give me a minuscule number on my calculator. It's giving me 0.000, so we can discount that and just take the 40. And plus 0.2 divided by 0.98, it's going to be plus minus that, so it's going to be minus 0.204, so just 0.2. So 39.8 meters traveled in the first 4 seconds.